So I'm recording now. Last day we started this concept or this topic 20 of rational expressions. And so I'm just scrolling up here. We looked at how to solve them, or fractional exponents, I guess is what we would call this, or radicals. So I'm going to get started or begin, and I'll start by just mentioning for you guys, if you were not in yesterday's class, this is a pretty straightforward topic. This part is straightforward. You can just enter these numbers in on your calculators. So if you have a Casio or a scientific calculator, you can enter the number and then put them to the power of this exponent, and it pretty much solves itself, so pretty easy. Today, however, we're going to look at something you can't do on your calculator, which is using X or Y or A and B. These are things that you can't do. So these examples today, I'm going to slow down
Mister,
a little bit and go through these because we
Mister,
can't use, one second, we can't use our calculator for this. Yes, you have a comment?
in practice I or practice L, I can't answer these questions. How can I answer it?
This one here, right? Sorry.
Yes.
Yeah. Okay. Hold on. Give me 1 second here. My mouse or
In the calculator, it's give me error. How
okay.
can I?
Yes. Okay. So this one, like if you look at this row of questions or whatever, the difference here with L is that it has a negative in there. So we can't, like your calculator won't take the square root of negatives, because what that ends up being is what we would call an imaginary number. A calculator, like if you tried to do the square root of -4 on your calculator, it will say error. So how do you get around that? Well, you do it without the negative sign and put in I for an imaginary number. Again, like, the square root of -6 or the square root of negative, I don't know, even A, like anything is going to give you an error. So what you do to do something like L on your calculator is you put it in without the square root sign. So let me zoom in here, or sorry, you put it in without the negative sign. Sorry, just zooming in here.
So the answer will be 1/27I.
Yeah, exactly. So what I'm going to do here is I'm going to remove the negative and put it as an I. Now, let me rewrite this, and we're gonna talk more about this today. But when I write this, if I was going to write this down on the paper, I would say that this is root 4. So this is called, it's not a square root, it's root 4. -81 cubed. Okay, so this is this guy rewritten, but because there's a negative here, I'm going to put an I outside, and I'll write it as 81 cubed, and let's see what we get. So I'm going to put this in on my calculator. On my calculator, you could, let me just get rid of my equal sign. On a calculator, you could enter this like this. You would say 8 -3/4, and you would put the I outside. So let's see what I get here. Oops, and this should be negative as well. So let's see what I get here. So on my calculator, I'm just going to enter 8. I'm going to raise it to the power of a fraction. So I'm going to say -3/4. give me 1 second here. Okay, so what this ends up being is on my calculator, it will be, it's giving me a decimal. Hold on 1 second. Just give me 1 second here. Okay, sorry. The calculator is giving me a decimal. It's saying 0.210. It's not letting me, or it's not giving me a fraction for this. So this is fine. This is what my calculator is giving me. If you did this without the calculator or manually, what you would end up getting, well, no, I guess that's it. Yeah. I mean, this is the answer that the calculator is giving me. So that's fine. Yeah. The I comes from the fact that I can't take the square root of a negative number. So I put the I there to say that it's imaginary. But yeah, that's a fine answer, or an acceptable answer, I guess, for this case. All right. That L is a little bit weird because, again, it is.
Thank you.
No problem, no problem. L is a little bit weird because it is an imaginary number. Okay. So let's look at these, converting between fractional exponents and radical notation. So for anybody who didn't understand question L, we're going to practice this a little bit more using X and Y. Let me zoom out a little bit. There we go. Okay, so it says convert each expression to radical notation. Assume all variables represent real positive real numbers. So we're not going to deal with any imaginary numbers here. So just remember, before we start A, just remember that, if I have x to the 1/2, this would be the square root of x. And technically, I would put a 2 here. So the number in the bottom of this fraction would equal what goes in front of the root sign. So if I had x to the 3/2, it would be a square root again, but x would be cubed. So the number on top is going with the x, and the number on the bottom is going with my root sign. And this will give you like a squared root or a cubed root, or different numbers depending on what question we're doing. So you can really see this here if I get rid of my writing. For question number A, so I have a 3/5. This would become 5 root a to the power of 3, which is, again, where this answer comes from. And I would do this for each of these problems. B, C, and D, very easy. I'm going to show you some more examples of this. The only thing I want to note, or only thing you guys should note, is that if it's negative, remember what we would do with negative exponents before. If I had x equals -1, that is the inverse, or we put it 1 over that term. So if I had something like a to the -2, that would be 1 over a to the +2. We did this all the way back in topic 4. If you guys can remember topic 4, it was like a month ago. But if it's a negative exponent, we would write it as what we would call the inverse. So let me show you some examples of this. Oh, there's more. Sorry, like what I want to do is I want to show you these. But let me check the chat first. Okay, I'm checking the chat there. Okay, chat. Sorry, there's not much to say in the chat. Santa had a good point, and there's a private message I have that says these questions are for the previous example. Why don't we write that there isn't a real solution? You could write that down, that there's not a real solution when you get an answer with an I. Okay, so these examples here are going backwards, or sorry, not going backwards, but going in the other direction. We're going to write each expression using fractional exponents. So this guy, we have the square root with a 4 here over b, or sorry, for b3. So this would be b3 over 4. If you just, like for number b or letter b, if you just see this and you don't see a 2, this means that there's secretly a 2 there. So when, like in math, if somebody just writes x, it's technically equal to 1x. If somebody writes the square root, it's actually equal to 2, or the square root. So well, let's practice. Let's look at some of these. I mean, it's hard to do these questions until I practice them with you. So how about I do A, B, C? Or actually, maybe I'll do A, B, D, and then you guys try the next few. Okay, so question A, it says convert each expression from a fractional exponent to the radical notation. Well, x2 over 3. Well, this is going to be, my root x here, but I'm going to put a 3 here and a 2 here. That's it. That's done. Halas, finished. So the 3 on the bottom of the fraction goes in front of my square root sign, and then I keep the squared. For b, the same thing. So I'm going to write root y. I'll put a 4 here and a 3 here. Done. Now it gets a little bit more.
There are 6, teacher.
Oh, a 6.
6.
Yes, thank you. 6. Perfect. Sorry about that. Yes, there is a 6 there. Okay, I'm going too quick, so I'm leaving out numbers. Okay, so what about D? D says QR. Okay. Well, QR, I'm going to, now, this is not the answer, but I'm going to write QR here. I'm going to put a 5 here and a -1 down. Now, I'm not finished. This is good, but I'm not finished. Because this is a -1, I'm going to rewrite this with my 5, and I'm going to go 1 over QR to the power of 1. The negative means I flip the equation, or I flip the expression and write it as a reciprocal, is what we would call this in math. Hold on, let me write that again. It was a little bit messy. There we go. And I could raise this to the power of 1, or I could not. Like anything to the power of 1 is just itself. So you could put the 1 in, or you could leave the 1 out. It's not going to change the equation. Okay, so I'll give you guys a minute or two to try these. Maybe you could try C, E, and F, and I'll be back to check your answers in just a minute. Okay, let's check out our answers. Oops. Okay. So I gave you. I guess I gave you guys the hard ones. I did the easy ones, but it's still pretty straightforward. What I'm going to do for C?
Mister?
Yes.
Mister, there is wrong in answer B because there is no bracket. So 6.
Yes, the 6 are out.
Yeah, yeah, you're right. I'm laughing because yes, you're right. If you guys look at number B, how am I going to erase this? Okay, give me 1 second. Yeah, you're totally right here. Hold on. The problem with B is, just give me a second to erase it. There was no bracket. So the y 3 to the power of, y to the power of 3/4 was no bracket. So this would be 3y4. Yeah, good. Excellent. Okay, so for question number C, there is brackets for question number C. So I'm going to take the whole thing. I'm going to put a 3 here, and I'm going to go x squared y. You don't. That's it. That's it for number C. For E, a little bit more work here. Again, there are brackets. So brackets means I'm going to take the. I don't know what to call this. Like I want to say square root. It's not. It's like it's not cube root. It's not square root. It's a root with the power of 4 inside.
6 over x.
Not 6 over x because there's
1 over 6x.
Yeah, there's brackets here. So I'm gonna write this
1 over 6 over 1.
No. What about your x? Don't forget your x. So what this becomes, because this is a negative, I'm going to rewrite this as 4, and then it would be 1 over 6x. As I think I heard by now, it's June 3rd. I know Nasser's voice. I think Nasser said 1 over 6x. So yeah, there we go. Okay, what about F? Now, F has brackets, but the negative is outside the brackets. So I'm going to leave the negative out of this calculation, and this would just be the square root of 9x. And the negative stays outside because it's not in the brackets. All right, cool. This is looking okay. This looks pretty straightforward. What about these? Here, I want to take the radical and put
the reverse.
The reverse, yeah. I want to take the radical and turn it into a fractional exponent. Sorry, I'm just reading the chat. Samira in the chat said you can't write the answers. And yeah, like if you guys are trying to write this in the chat, it's very hard. So don't worry if you can't write this down. Okay, so we're going to do the reverse of this. So for example, A would just be x to the power of 1/3. B would be 10 to the power of x to the 1/2. Now, one thing to mention about B, if you don't see any numbers there, like B is just square root of x. I know the 10 is there, but the square root of x would be x to the 1/2. If you don't see any numbers or any negatives or anything like that, it would just be a square root. It's kind of like a math shortcut. So for B, oops, this is just x to the 1/2. I put my x in brackets. You actually don't need to do that. You could, if some of you were doing B and you just said 10x to the 1/2, that's fine as well. I like to use brackets, but you don't need to. So I'm going to stop talking. I'll give you guys a minute to try the rest of these, C, D, E, and F, and then we'll move into something a little bit more complicated, properties. Okay, so I'll be back in 1 minute. Good luck. All right, just one more minute and we'll look at the answers. Okay, let's look at the answers. I noticed Nasser, you raised your hand. Do you have a question?
Mr. Mark and letter F, A, B, C are together or they're separate?
They're okay, so that's a good question. So in
Between
F,
two brackets.
yeah, in F,
Two brackets A, B, B, C, power 1/2.
yep, exactly. And in F, so the question from so
Okay,
thank you for
thank you.
that. That is the answer. That's perfect. The question from Nasser was, are they together or are they not? Like, you know, or is ABC multiplied together? Well, they're all under the root sign. So that means that all of these letters, A, B, C, are together.
I put the answer without brackets. Is it okay, or I have to put the bracket?
Okay, so if you wrote this A, B, C, 1/2.
That means C is power half.
Exactly. So that's not okay because what you're telling me as a math person is that you're only taking the 1/2 for the C. Yeah, so you do need brackets here. That's a really good question. Same thing for C actually, or for E actually. For E, it's the X and Y together are going to be to the 1/4. All right. If you got, I just don't. Yeah, no problem. Okay, cool. Okay, so for C, the -5 is not included, so this would be. Oops, sorry. This would be -5x to the 1/3. Guys, if you didn't use brackets for C, that's okay because you could say -5x to the 1/3. You don't need brackets for C. For D, you would say y squared over 3. All right, that's it. Pretty straightforward. So let me check the chat and then we'll move on. All right. I will scroll up for a second, but now what we're going to do is we're going to use the properties of these exponents to simplify these expressions. Now, this table or this information we did all the way back in topic 4. So this is a review for everybody, and I mentioned this in yesterday's class. So if you weren't here yesterday, I looked over all of these properties. So let's put them to work. Again, I won't reteach the properties or anything. We did this in topic 4. I looked at this yesterday. Let's look at some examples. It says, use the properties of exponents to simplify these expressions. So there's A, B, and C. And we'll look at 3 of these. Then maybe I'll do a few of these. Ooh, I'll definitely do number B for you. And then I'll get you guys to practice. So question A, we have y2/5 times y3/5. Well, what that means is when we're simplifying this, we add the exponents. Again, I'm going over these properties. So like for A, if I had x squared times x to the power of 5, you would say that it's 5, x equals 7. You would add the exponents. So this rule here says I'm going to add these exponents. So for question number A, 2 over 5 times 3 over 5, I'm going to add my exponents. 5 over 5 is the answer, so this would just be y1. And again, I'm going to practice some of these with you. Okay, what about B? B looks crazy. There's a lot of B looks intense, but what we're going to do first for B is I'm going to multiply everything by 4. So you can see here in the second step, everything gets multiplied by that 4. All right, and that's it. And then I simplify, I multiply everything by 4. I reduce my fractions. If I need to, done, halas, there's the answer. So for example, if you're looking at the S term, 1/2 times 4 is 2. If you're looking at the T term, 1/3 times 4 is 4 over 3, and so on. And again, guys, I'm going to do some of this with you. So question number C has a lot of information going on. So the first thing I'm going to do with question number C is I'm going to multiply everything by my exponent, 1/3. So the 81CD, sorry, I'm just reading the chat here. Or sorry, not reading the chat, I'm reading the question. Why does it get me to do that? Hold on. I think there's like a typo here with question number. Yeah, like.
Yes, I think 81 powered by 1/3. Something is wrong here.
Mhm. I agree with you. I agree. I think this one has a mistake.
Maybe he divide 81 over 3 gives 27. I don't know.
Oh yeah, the 27.
Ah, he divided after he
Yeah.
put the 1/3.
The 27 is okay. It's what's giving me a problem, or what's confusing me, is the C. If you look at this question, the C is not raised to the power of -2. I don't know where, what I'm saying is, I don't know where this comes from. See what I'm circling? I'm very confused about that. I think that's a mistake.
I think because the top is C, so 1, and -2, it's for down. So 1 minus -2.
Yes, yes, you're right. Okay, I didn't even see that. So guys, I'm looking at this as like piece by piece. But yes, you're absolutely, you're like, oh my God, I wish I could give you 100 marks.
Yes, please.
Where this comes from is from the C on the bottom. I didn't see that. Again, like I'm looking at just the top. I wasn't really thinking about the whole problem. Okay, so yes to everybody. 81. So, okay, what I'm doing is I'm following BEDMAS, right? So I'm solving the brackets first. I'm doing what's inside the brackets first. And thank you, everybody who's helped me with this one. So 81 divided by 3 is 27. Now I have a C to the power of 1, and I'm dividing it by -2, which means I subtract the exponents. That's where that comes from. And the same thing for D. I have a -2, and I'm going to subtract from that a -4. That's where all that information comes from. And if any of you are confused, don't worry. I'm going to do some with you, I promise. So once I do all of the things inside of the brackets, now I can raise it to the power of 1/3. So 27C3 times D to the -6 I move the d to the bottom of the equation, and now I solve. I put everything to the power of 1/3. And that's where I get this. 27, the cube root of 27, or 27 to the power of 1/3. You can do this on your calculator. It's just 3. If you guys are wondering where the 3c comes from, it's because I take the cube root of it. Okay, let's do some together. Thank you for that, guys. I'm definitely going to do a harder one. And then we'll look at topic 21. So let's do an easy one together. Let's do A and B. And then I'll do a hard one with you, something like, K or L. And then I'll get you guys to practice. Okay. So question letter A, or number A. X to the power of 1/4 times x to the power of 5/4. Now, this means what I'm going to do with my properties of exponents, I'm going to add these together. Okay, and these are exponents. You can do this on your calculators if you want. I'm going to take 1/4, so 1/4, and I'm going to add this to a negative 5/4. And you do that on your calculator, and what you'll get is x equals -1. Or sorry, when you solve this, you'll get -1. Oh, is that right? Oh, yeah, I'm reducing this. Sorry. So, sorry, I did this on my calculator. What you'll get is you'll get a -4/4, which is x equals -1. And this is okay, but if I wanted to simplify this, it would be 1/x. X to the power of -1 would be 1/x. All right, cool. What about question number B? Well,
Minus.
yeah, exactly. These are divided. So what this means is if I'm going to write x 5/3 divided by x 2/3, what I'm actually doing is I'm going to
5 minus 2, 3 minus 3. I think so.
yeah, maybe. I'm sorry. So yeah, I'm going to subtract, my exponents. So when I subtract 5/3, subtract 2/3, what I end up getting is x is 3/3, or just 1. All right. Pretty, I was going to say easy. It's not easy. If any of you guys are like, what is happening? Just remember from topic 4, you need to know these properties. I'm applying these properties to do this. So let's look at a harder one, and then I'll give you guys the chance to try this. What do I want to do? Well, I can do K. K looks pretty challenging. All right, so let's look at K. Okay, so the first thing I'm going to do with number or letter K is I'm going to look inside the brackets, see if there's anything I can do. There's not anything I can do. So now what I'm going to do is I'm going to multiply the 6, and in this case, multiply the 2 by both of these terms. So what I'm going to get is bracket x is equal, so x squared, I'm going to multiply that by 6. Y -1/3, I'm going to multiply that by 6. And then in the other bracket, I have x x to the power of 1/2. I'm going to multiply that by 2. Y, I'm going to multiply by 2. And z, I'm going to multiply by 2. So 2/3 times 2. Okay.
The exponents can be multiplied on the calculator, right?
Oh yeah, totally. Sorry, that took me a minute to think about. Yes, like something like 2 times 6 or 1/3 times 6. You can totally do this on your calculator. So I'm going to get x 12. Y will be -2. Again, you can do this on your calculator. Then I'm going to get x1, y2, and z 4/3. Now I'm almost done, but I'm multiplying these numbers together. So I might as well keep going. This is going to be 13x. Ooh, this is interesting. Y0. -2 and +2 means they will cancel out or be to the power of 0. I'll explain that in a second. And then z to the 4/3. Now, a lot of you guys might be wondering, whoa, y to the power of 0, isn't that a 0? It's 1, exactly. Anything to the power of 0 is 1. So this would just be x13 z 4/3. Done. Y to the 0 equals 1. Any number in mathematics to the power of 0 equals 1. So 1 to the 0, 10 to the 0, 50 to the 0 equals 1. All right. So I'll give you guys a couple of minutes to maybe try these examples, and then we'll look at the answers, and that's it. Sorry, that's not it for today, but after that, we'll go into topic 21. Okay, so I'll give you guys a couple minutes to try I, J, and L, and then I will be right back.
How can I answer L? It's too hard.
Okay, let's look at the answers to this. I'm getting some answers in the chat there. Let's see what we get for this. So for question number I, what I'm going to do is I'm going to try to simplify this first, meaning I'm going to do what's in the brackets first, and then I'll worry about the 1/3 on the outside. So what I get, 16/2 is 8. And then for the x's, I'm going to get -2 minus 1. And for the y's, I'm going to get 1 minus a -8. Okay, so, and then of course, all of this is out,
-3.
to the power of 1/3. Yeah, so exactly. So what I end up getting is I get 8 x to the -3, y to the +9. And I'm going to take the cube root, or I'm going to multiply all these by 1/3. So what this ends up being is 8 to the 1/3, which you can actually solve that. The cube root of 8 is 3, but 2, but I won't do that yet. X is going to be -3/3, and y is going to be 9/3. So what this ends up being is 2. Now, if you don't know where I got the 2, 8, you can do this on your calculator. 8 to the power of 1/3 is 2. X, I get -1. And y, I get 3. So finally, my answer will be 2y3 over x. If you said this, what I'm putting the cloud around or like the circle around, that's fine. This is a good answer. But when x to the -1 is actually 1 over x, so I put the x on the bottom to be kind of like a perfectionist, but that's fine. So this is fine, but the proper answer would probably be the bottom one. Okay.
Would we lose marks for it? Or?
No, you won't lose marks. No, this is fine. Yeah, this is the top answer is totally fine. Okay.
Okay.
So let's look at letter J. Now, J, actually, I was a hard one. J looks to be pretty easy. What I'm going to do for J is I'm going to write everything to the power of 1/2. So I'm dividing everything by 2. And what I end up getting is 5x y squared z 3. This one's pretty, I don't know why I can't write 3 today. There you go. This one's pretty easy. Letter J was a pretty easy one. Okay, so let's look at L. Okay, so L, there's nothing I can do here in terms of simplifying it. I'm just going to multiply this by everything. So I end up getting, oops, sorry about that. There we go. So I end up getting x3m over m, y2m over m divided by z or z5m over m. So what I end up getting for my answer is x3, y2, z5. The m's are canceling in each situation. So, pretty easy question. It looks like I did some of the hard ones. All right. So let's do one more topic here at least. We'll look at topic number 21. Sorry, 1 second. Sorry, I'm just looking at the next topic. Okay, yeah, so let's do one more topic. Excuse me. And that'll be it for today. So there's a lot of information here. So that's why we're only going to do one more. Topic 21, simplifying radical expressions. So first of all, it mentions at the beginning the properties of radicals. When simplifying radical expressions, we can use multiplication and division properties to kind of help simplify these. So, your calculator can do this. This doesn't really work for if we're picking like X and Y. But the square root of 144, well, we can simplify this to be the square root of 16 times the square root of 9. 144 is 16 times 9. So then we get the answers here. We would get 4 times 3 or 12. Now, again, your calculator can do this, so it's not really that important of a property. The reverse of the property is also true. So the square root of 3 times the square root of 12 would be equal to the square root of 36. So we'll look at these calculations in a minute. And you can see the rule right here. So it says let A and B represent real numbers. The square root of A and B are therefore both real. So we get two properties here. Property 1 says that the square root of A times B is equal to the square root of A times the square root of B. Again, we're going to practice this, don't worry. And then number 2 says, well, what about A divided by B? These are equal to the square root of A divided by the square root of B. And this, the second rule is only true as long as B equals, or sorry, does not equal 0. So again, we'll practice this in a minute. So to write the simplified form of a radical, the method is consider any radical expression. The simplified form is true if these three conditions are met. The radicand, meaning the number inside the radical, has no factor raised to a power greater than or equal to the index. We'll talk about this in a minute. The radicand does not contain a fraction, and there are no radicals in the denominator. So let's practice this. Let's look at this. So if you look at this example here, okay, there's three different examples. The expression root, this cube root or 3 root x to the 5. This fails rule number 1. It's not simplified. The radicand has no factor raised to the power of the index. So this is not simplified because this power, this x number is raised to a power. So simplifying this would be x to the 5/3. Number 2, the expression square root of 1/4 fails this test. It does include a fraction. So the expression square root of 1/4, it does have a fraction. So this fails itself. You would simplify this as 1/2. Square root of 1 is 1. Square root of 4 is 2. Number 3, this expression fails the rules because there is a radical in this denominator. So to simplify this one, we would say 1/2. The cube root of 8 is 1/2. So all of these could be simplified. That's the key. So what we're going to do is we're going to simplify these fractions or try to simplify these examples. So I'll look at A, B, and C. You can see here. Then there's more examples. There's another A, B, and C, and then we'll do some practice. You guys will practice, and then halas, that's it. Nasser, you raised your hand. Yes.
Mr. Mark, some of these questions could be put in the calculator? Or?
No, unfortunately, that's a good question. Unfortunately, these questions cannot be put into the calculator because they involve variables. So,
because there were some examples with the like 1/a square root cubed, like over 8, and there's no question like that, or
no, not really.
It's just an example.
This is just an example. Maybe later on, like something like 28 or 80.
Yeah.
You can put these into the calculator, but something like A, B, C, and D, you cannot put into the calculator.
Okay, gotcha. Thank you.
No problem. Okay, so let me do a couple of examples. Oh, I hate this. Like, I hate going through examples from the book here. I'd rather do them with you. But anyways, let's look at some of these.
Mr.
And
Here
then,
in the last thing, can I put it x power 4, x power half?
what question? What number?
A.
A? Like this, like this one? A right here?
Yes, this one. Can I put it x power 4 multiply x power half?
Okay, so I kind of know what you're saying. So for this one, square root of x to the 9. Oops, sorry. You could say the square root of x to the 4 times the square root of x 5. But like, again, that's not going to give you the answer. So yeah, no, no. The answer is no. Okay, so for A, question A, x to the square root of 9. Well, the expression x to the 9 is not a perfect square. There's no number squared that will give you 9. So what we're going to do is we're going to write it as the product of the largest perfect square, or basically the largest even number, and write what's left over. So x to the 8 is a perfect square. Now, why? Why is x to the 8 a perfect square? Well, this is x to the 4 times x to the 4. Literally the definition of a perfect square. So x to the 9, not a perfect square, but I can rewrite this as x to the 8 times x, which would be my 9. So, x to the power of 8 times x is 9, or 9 x's. And now I can take the square root of this. 8 to the power of x is a perfect square because it's x to the power of 4 times x to the power of 4. And now I can simplify that answer. So A becomes, I take the square root of 8 to the power of x. It's x to the power of 4 times x. So again, we'll do some of these for practice. So what about question number B? The goal here is to rewrite the number under the root sign as the product of the largest perfect cube and then what's left over. Now, why the largest perfect cube? Well, this is the cube root. So what I'm going to do is W7Z9, I cannot divide by 3. That's the key here. So W7Z9, I cannot divide by 3. That's really what I'm looking for here. So what I'm going to do is I'm going to remove a W from this, as you can see here, to get the W equal to 6, and then I can remove it by, or I can remove or cube root it by dividing by 3. So for these questions, you're looking for a radicand, which is the fancy term for something under the radical sign that you can divide by the number in front of the radical. So if you look at C, I have 4 root B7. Well, there's no way to divide 7 by 4. Again, what I'm trying to do here is I'm trying to take the 7 and dividing it by 4. I can't do that. But what I can do is remove 4 b's, which will leave me with B4, B3. And then I can take the cube, not cube root, but like quarter root of this. So we'll practice this in a minute. Let me just get rid of these, or like get through these examples, and then I'll show you. So you can do this with actual numbers like an A, B, and C. There's numbers in front of here. For question number A, I can factor the radical or factor the radicand, the number under the root sign, and I can remove the factor. For B, I can do the same thing. I can factor it and remove the radicand. And like, I guess it's probably just easier for me to show you this. So let's look at some practice examples. Okay, so let's look at number A. Let me zoom out a little bit. There we go. How do I do this? How do I simplify these radicals? Well, this is a square root. What I mean is this symbol is the same as saying x to the 11 to the power of 1/2. Now, I cannot divide 11 by 2. There's no, like, meaning it's not going to be a nice number. But what I can do is rewrite this radical as x to the 10 times, x. So x to the 10 times x is x11. I'm not changing anything. You know, everything's the same. And now I can actually solve this question. So this becomes the square root of x to the 10 times the square root of x, which is going to be x5 times root x. X to the 10 times 1/2 is a 5. So x to the 5 times x. Let's look at another one. How about I do question C? So again, what I'm doing for C is I'm taking a to the 5, b to the 4, and I'm raising it to the power of 1/2. Now the problem here is that the 5, I cannot divide 5 by 2. So what I can do is take the square root of a, and then I'm going to go a times 5 times b times, I take an a away, so this is a times 4 times b times 4. Now I can take the square root of everything. This will end up being root a times a4 b4. So what I end up getting is a squared b squared times the square root of a. Okay, let me try one more, or let's do together one more, and then I'll get you guys to practice. So I'm going to get you guys to do B, D, and E, but let me do F. Now, the problem with F is the square, well, actually, the best part about F is you can do F, like I said to Nasser earlier, on your calculator. So if I take the square root of 80 on my calculator, it gives me the answer. This would be the square root of 16 times 5. My calculator will just give me the answer of 4 root 5. Sorry. So you can do something like E and F on your calculator. And what I want you guys to try is to try B, D, and E. Now, B and D you can't do on your calculators, but E you certainly can. I'll give you a minute for this, and then that'll be it for today. So just take one more minute, try B, D, and E, and we'll look at the answers. All right, we'll look at the answers in just a minute. I'm going to read the chat here. All right, so let's check the answers. I'm getting some from Samira and Sana. I'm getting some good answers here. So let's see. Let me get rid of my writing first. There we go. Okay. So let's look at B, D, and E. Okay, so B. Let me zoom in. No, I'll leave it like this. Okay, so B, I mean, you can rewrite this as Q to the power of 7 times 1/3. The problem with B is 7 does not divide by 3. So what I'm going to do is I'm going to rewrite this as Q over or Q to the power of 6 times Q to the power of 1. And that will let me divide that by 3. So what I'll end up getting is Q2 times Q, the square root of Q. Phew, looks a bit crazy, but no, that's the answer. I can take the cube root of q to the power of 6, it's going to be 2, and that leaves me with a q. Okay, what about D? Now D, don't worry about the negative. The negative has nothing to do with this question. So this is going to be negative x to the 8 times y to the 13, all to the 1/4. Now the problem with this question is the y cannot be divided by 4. So what I'm going to do is I'm going to rewrite this as negative. The negative stays. I'm going to write this as the quarter or whatever this is. Again, I want to say like square root or cube root, but I can't. So like the quarter root of x to the 8 times the quarter root of y to the 13. And I need to think of a number that's going to work for y. So this will be x squared. But what do I do with the y? Well, I'm going to remove one of the y's. So this will be y times y12. And what I end up getting is negative x squared times y cubed, right? I can divide the 12 by 3 times the square root of y. All right. And then the last one, the last one.
4. Yes. 4 squared by y.
Sorry?
The last thing. 4 square y.
No.
Cubed square y.
Nope. This is the answer. Negative x squared times y to the power of 3 times the square root of y. There's nothing else I can do. I don't know where you're getting a 4. This is the answer. Okay, so for E, E is lovely. I can just put this in on my calculator. So I'm going to go square root of 28. And then I get 2 root 7. If anybody's wondering where that comes from, you can change this to the square root of 4 times 7, which is where I get the 2 root 7. All right, guys, so that's it for me today. Have a good weekend. If there's any questions, let me know. But other than that, yeah, I'm done. Halas.